Hello and welcome to my channel MathyThinkers. In this video, we are going to look at length of an arc and area of a sector. If we have a circle and we cut a slice out of it just like this, we call the two pieces as two sectors. So this little one is the minor sector and that big one is the major sector. So a sector is an area bounded by two radii and an arc. So this is the arc and those two are the radii of this circle. We know that the total length of the circle is known as its circumference and is given by the formula of 2 pi r. So 2 pi r is the circumference of this circle. Now, if we are asked to find out the length of this part only, the length of this arc, so we have to see what fraction of the total length is that L. So in order to find that, what we can do is we can take a fraction of the angle subtended at the center. If the angle subtended at the center is theta, and if theta is in degrees, then the fraction will be theta over 360 degrees because this total angle at the center is 360 degrees. So if theta is in degrees, then the length of the arc should be theta over 360 times the total circumference, 2 pi r. In other cases, if the theta is mentioned in radians, in that case, we will do theta over 2 pi times 2 pi r. This is because 2 pi is equal to 360 degrees. So in the second formula, if this 2 pi and 2 pi cancel out, then the length of the arc is theta times r, if theta is mentioned in radians. So this is the length of the arc. In some questions, we might require to convert from radians to degrees or from degrees to radians. In such cases, we should know the conversion rule, right? So we have to remember that 180 degrees is pi radians. So 1 degree should be pi divided by 180 radians. So if we are given a degree maybe of an angle of 10 degrees, so we will just multiply 10 by pi over 180. And that should give us maybe 0. So on a calculator, it will give us 0.175 radians, approximately, rounded to 3 significant figures. Okay, now if we have the angle given in radians and we want to convert it to degrees, then we apply this rule. Pi is equal to 180 degrees, so 1 radian should be 180 divided by pi. So if we have 0.175 radians, 0.175 radians given in the question, and if we need to convert it to degrees, we'll multiply that 0.175 by 180 degree over pi. 180 over pi. So we will have 10 degrees approximately. Now let's learn about the area of a sector. So we know that the total area of a circle is pi r square. So again, this area of this minor sector should be theta over 360 times pi r square, where theta is in degrees, because the fraction of this sector is theta over 360 of the total area. Similarly, if theta is in radians, it should be theta over 2 pi times pi r square. So if we simplify the second formula, we get half theta times r square. Let's look at one example here now. The question says, the following figure is a sector of a circle with radius r centimeters. If the area of the sector is 300 pi, find the value of r. Here in the question, they have given 60 degrees as the angle subtended at the center by this sector. So let's apply the formula for the sector. So we know 60 over 360 degrees times the total area, which is pi r square, should be the area of the sector, which is 300 pi. So that's given. So now if I simplify this fraction, I should get 1 over 6. So now pi r square should become 6 times 300 pi. So r square should be 6 times 300 pi divided by pi. Divide by pi. And if we square root that, we should get the value of r as 42.4 rounded to 3 significant figures. This is rounded to 3SF. Rounded to 3SF. 3SF. And its unit is centimeter because it is said r centimeters. So r is 42.4 centimeters. The next question says, if the area of the major sector is 240 centimeters square, find the perimeter of the major sector. Now, in this picture, we have been given the angle made by the minor sector. So, the angle made by the major sector should be 360 minus 60 because 360 is the total. So, this one should be 360 minus 60, which is 300. 60, which is 300 degrees. That is 300 degrees. Now we will apply the formula of the area of the sector here, of this bigger major sector here. So that's 300 out of 360 times the total area, which is pi r square. Sorry, pi r square. That should give us 240 centimeters square. So if we simplify this, we will get 5 over 6. Now, if I solve for r from here, I'll get 240 divided by 5 times 6 and divide by pi also and square root of that. Right? So 6 times 240 divided by 5 pi. And that should give me approximately 9.575 centimeters. Now, We have been asked to find out the perimeter of the major sector. So the perimeter means all this length, excuse me, plus this length and that length. So that should be the perimeter P should be equal to the arc length, the length of this arc, that's L plus the two radii, this R and that R. So L plus 2R. Now if I apply the formula for the length of an arc, that should be 300 over 360 of the total circumference times the total circumference, which is 2 pi r, plus the 2r. So if I calculate that, putting the value of r as 9.575, I should get approximately 69.3 centimeters, rounded to 3 sm. So this is my answer for the perimeter of the major sector. Thanks for watching. If you like my video, press like, share, and subscribe. And don't forget to follow me on Facebook and TikTok. Thank you.